Now, as promised in a previous video when we took a look at this little Yagi, PCB Yagi here, I did say we were going to do some rapid prototyping because I wanted to figure out the measurements for a 2.4 gigahertz Yagi using the same form factor as this. Now, it's something that I haven't shown on this channel before, but it's something I do quite regularly, especially when it comes to filters and that sort of thing. If I want a one-off filter, I will just make one from copper tape, and we've got some copper tape here of different dimensions. This is 50 millimeters wide, this one is 10 millimeters wide, this is 20 millimeters wide, and I haven't got a lot of this left, but I normally pick this up from the garden centre for £1. It's really cheap stuff. It's slightly more expensive on eBay, but it's spring soon, so I'll be able to get my hands on some more of this. And I've got some copper tape here that is 5 millimeters in diameter. You can get this in 70mm and 100mm. I haven't got any in stock yet. I've just ordered some because when it came to shooting this video I realised I used it all last year. But basically you can come up with all kinds of creations using copper tape, especially if it's just a prototype. It's a lot more feasible than etching, to be quite honest with you. I would normally start off with copper tape on some blank FR4 board and prototype something before I even move on to etching. And then of course once you've etched it, and if it's something you want to make lots of, then send it out to have them made. But we're going to use this as the basis. This is some FR4 board. It's some single layer board, copper clad board, that I just etched the side off, so we've got a nice flat surface. You can use this many times. I mean, this is a new piece, but what will happen in the end, you'll get lots of different cuts into this and it'll just get messy. And you know, you can pick this up pretty cheap off eBay, to be quite honest with you. Single-sided copper clad board. I think this one only cost me about £1.50, and it gives you a nice footprint to build on. And remember, you can build something really small in the corner here just because it's a big sheet. You don't have to use it all, and you can do many things with a piece of FR4 board like this. Now, you also have to think about what it is you're creating. I mean, you can only do quite simple things, although the way they work can be quite complex. But for instance, on this here, we've got this feed here going into the cutoff of the little patch antenna here, and joining the copper up can be done. You can solder joint and bridge across, but it's a little bit messy. So what I've decided to do here for a first prototype is I've got a little SMA connector here. This is the kind of SMA connector which will just slide onto the PCB, so we don't even have to solder the ground anywhere. And I've extended this out with a line here with a feed, so what we can do is just use that for this part here, and then I can solder this straight onto the copper. It means I don't have to mess around bridging things. But yeah, these are pretty cheap as well. You can buy a bag of these, a bag of 10 from China for about £3 and free shipping as well. Now, of course, you're going to need some kind of measuring device. Here I've got a ruler, and I've also got some digital calipers. You could probably get away with a ruler at 2.4 gigahertz, but the calipers just make it a little bit easier. I mean, again, these are just cheap calipers. You don't have to spend a great deal of money. And of course, you're going to need a sharp knife, and I'd choose one with a brand new blade as well. Now, before starting this, I did sit down and try and work out the measurements based on my own experience of different antennas and different things in the past. And these are the measurements that I'm going to use as a starting point. And I've taken into consideration the design of this and the spacing between the parasitic elements, the spacing between the back reflector, and I've just extracted that using percentages to what I think it would be for 2.4 gigahertz. The patch antenna is one. I got the measurements off an online calculator, and I just, you know, put in there we're using FR4 board. I also put in that the back reflector, because remember, calculators are very basic things. It gives you a starting point, and it didn't like the fact that I didn't have a back reflector, so I just put it as 1, and I've also got a couple of little patch antennas for 2.4. So these are the measurements that we're going to start off with: 38.7mm by 30.4mm. Now these little bits at the end, I'm not going to add them in at this moment in time. We're just going to have it with the normal parasitic elements. This would be extremely difficult to do with copper tape, for instance. So these are the measurements that I've come up with as a starting point. We've got the back reflector, 70mm long, although that really doesn't matter. It's not going to influence the overall frequency, but we'll start off with 70mm with some of the 10mm copper here. Again, I like to round the measurements off so we can do as little cutting as possible. And I've got the patch antenna, as I said, 8mm away from the back reflector. Then we've got the parasitic elements. The first parasitic element is 6.6mm away from the main driven element here, the little patch antenna. The parasitic elements will go in just a little bit thinner than it is on this original one. We're going to use the 5mm tape. That's not going to matter so much in the overall frequency. What does matter is the spacings between those parasitic elements. The thickness of them isn't going to matter too much. So the rest of the parasitic elements are spaced out at 5.4mm. So we've got 6.6 and 5.4, 5.4 all the way to the end. Now the length of the parasitic elements that I've come up with to start off with is 28.2mm. So just slightly shorter than the overall height of my little patch antenna here. The height of that is 30.4mm. The parasitic elements are 28.2mm long. So that's going to be our starting point. And what's good about this copper tape is we can go in, we can replace it, or we can trim little bits off the main driven element just to try and get the frequency exactly where we want it. So it's nice to have a starting point, so that's where we're going to start off with. Now at the moment we've got a clean slate to work with, and the starting point, you may be thinking, well, we'll start off with the back reflector. Well, that's not a good idea. The best way to start off with something like this is with the main driven element, the little patch antenna here, because everything else is built off of this. We know the back reflector's 8mm away from the little patch here, and we know the first parasitic element is 6.6mm away. And it doesn't matter where we start on the board either. We don't have to have the back reflector right over here, of course. So I'm going to start off making the patch element first, and I'm going to place it in this area here and then work off that for the measurement where we're going to space out the back reflector and then of course the parasitic element. So I'm starting off with that first. So as I said, we're going to start off with the main driven element first. Now I've put some layout guides on here. I would normally do this with pencil, but you wouldn't see it on camera because I want to keep this as square as possible. As far as keeping it as square as possible here, it's going to make it a lot easier to trim down. So I'm going to stick it down onto the PCB and then trim from this edge here and trim from the top edge to bring it down to the correct measurement that we want. Now to get it to lay down, don't try and peel it off the paper all at once. Work in small areas, and a little rubber on the end of a pencil is perfect for this job. Now it's probably not going to show up too well on the camera, but what I'm going to do is just make a little mark with a pencil, and then I'm going to use a set square, because we know that this is nice and square and everything is relative to the bottom here. What I can do is use a set square and then use that, go down with the knife and remove this material here. Just makes it a lot easier, as I say, getting things right in the first place. So I've got my knife, and I'm not going to try and cut it all the way through all at once, because what can happen is you can end up tearing the copper. So I'm just scoring it across a few times just to cut through. And of course a spudger always helps. And the next measurement we need is 30.4. so again, same thing, use my calipers and put a little mark in there with my pencil, and exactly the same thing, score down, not cutting through all at once. Now the beauty of doing this is if you make a mistake you can start again. You can probably see I've got some score marks in my new board there because these measurements that I mentioned at the beginning, I've got them the wrong way around. This wants to be 38 millimeters high, millimeters there, and the top wants to be 30.4 millimeters across the top. So I've got those two measurements mixed up, but that's what the beauty of this is. It's easy to start again and rub out. If I were to etch this, then it's a wasted board. So I'm measuring from this side of the element, and this time I'm going to use the Sharpie so you can see it on camera. So just a little mark there, and again use my set square to draw the line. Now to cut the reflector the required length, I've drawn a centre line just here and carried a centre line across here as well with the Sharpie, just at the centre of the main driven element here. So because I want this to be 70 millimeters in length, we can just measure 35 millimeters here and 35 millimeters from here, cut away any excess. And the line is continued along here because that's also going to help us when we get to fitting the parasitic elements. So next we're positioning the parasitic elements, so I've drawn a line 6.6 millimeters from this edge of the main driven element. I've got a length of the 5 millimeter copper tape here. Not too worried about getting the length correct at this stage. I'm just going to be positioning them in place, making sure I've got lots of extra at either side that we can trim away later. So the next parasitic element needs to be 5.4 millimeters away from this first parasitic element here, and then it's the same with the rest of the parasitic elements. I'm just going to build a Yagi with 5 parasitic elements, so the rest is just placing them in, measuring off until we've got 5. So now, as you can see, I've got all 5 parasitic elements laid out, exactly spaced out at the correct measurements, and now I'm going to cut them all in one go to the correct length. So I've put a mark here and a mark here. I just divided the overall length by 2 and then use the center line to put the 2 marks in place. So now what I can do is use my set square and just line it up on that mark and then cut it with the knife. So this is our Yagi. We're ready to take it over to the test bench. We just need to attach the SMA connection. You'll also note that I've cut out a notch on the patch antenna just where I'm going to solder the feed to. You don't really have to do that. I mean, we're just prototyping at the moment. I could have left it just as a rectangle, but I've cut a small notch out. That's the kind of things we'll change as we go along, you know, on a first pass. So here it is on the test bench, and we'll take a look at the network analyzer. And it's not quite what I expected. So here we are on the network analyzer. We're scanning from 1700 megahertz over here all the way up to 4.3 gigahertz, and you can see we've got this frequency response here, and I've got the cursor on it, and it's at 3.3 gigahertz, almost a gigahertz away from where we actually want it. But there again, this is why we prototype. I wasn't expecting it to be that far off, but obviously it is. So these are the new measurements then that I've come up with, and I've increased everything by a third. So now the main driven element measures 51.6 millimeters by 40.5 millimeters. We've got an 8.8 millimeter gap between the driven element and the first parasitic element. Then the rest of the parasitic elements are 7.2 millimeters between each other. Parasitic elements now measure 37.6 millimeters, and we've got a 10.6 millimeter gap between the main driven element and the back reflector. The back reflector I've come in with a measurement at 85 millimeters, but I'm just going to leave it like it is on the board. It's not going to make a great deal of difference. Now this is a lot bigger this time, so hopefully, fingers crossed, we'll get more in that sweet spot for 2.4 gigahertz. Was a little bit taken aback how far off we were with the first one, but because we can rapid prototype like this, it only took me 20 minutes to lay this out on the board. It took me 20 minutes to work out the measurements, but to actually lay out on the board, only 20 minutes when I'm not filming on camera. So hopefully, fingers crossed, we're in that sweet spot. I do think this might be a little bit too big, but let's take it over to the test bench and have a look. Here we are then on the test bench, and things are looking a little bit more promising on the network analyzer. So here we are on the network analyzer then. This time I'm zoomed in a little bit, and you can see that we have overshot because we're at center frequency at 2.2 gigahertz there, so it's a little bit too big. We've got to remove some of the material, make it a little bit smaller by a couple of millimeters, and hopefully get it over here at 2.45 gigahertz, around that kind of area. So a little bit of a trim and then we should be there. So just double checking the measurements that we've just used, plus the measurements that we built the first one with. The width across here with the new one was 40.5 millimeters, and the height was 51.6. The original measurements here, this 40.5 millimeters was originally 30.4, and then the height was 38.7. So I'm kind of thinking we probably would be good if we trimmed 1.5 millimeters off along here across the top to reduce the height, and then trimmed a millimeter off each of the sides, and then take it back over to the network analyzer and see how that responds, and that'll give us a good indication then. So a millimeter off the sides and 1.5 millimeters off the top, and hopefully we'll get a good response. And here it is one last final time on the test bench. I did, since you last saw it over on the other bench, go back and take off another millimeter off the side. So we removed 2 millimeters off each side of this, plus 3 millimeters off the top, and now I'm happy with it. We've got it right where we want it. So here we are on the network analyzer then, and we've got this lovely frequency response now, right where we want it, 245 gigahertz for the Wi-Fi spectrum. We've shifted this from over here all the way to here by removing material off that PCB board, 3 millimeters from the top, 2 millimeters from either side. It's really done the job nicely. I'm really pleased with that frequency response just there now. So to conclude this afternoon's work then, these are the measurements that we started off with, and they were totally out of the ballpark. These are the measurements that we've ended up with. We first started out with 40.5 millimeters, and now we've got a measurement of 36.5 millimeters, and it's the same with the height as well. Started off with 51.6, and now we're at 48. It should be 6 and not 8, but 48.6 millimeters. So now we've got something that we can work with and take forward. As of the future of this antenna, I think these parasitic elements can be longer. I think I'll have a go one afternoon at making these longer. Of course, because we've reduced the material of the main driven element now, the spacing between this first parasitic element and the back reflector is now greater. So I'd want to bring those back in and see how that works again. But certainly looking at the length of these parasitic elements and the spacing in between them as well, to have a play around with that. But at least now we know we've got a good ballpark starting point with the main driven element. So yeah, it's an afternoon well spent. And of course you may be sitting there and saying, yeah, but there's software that does this, and this is true, there is software out there that does this, but software is only as good as the database that it's got to work its calculations from, and the bigger the database, the more accurate the software is, the more expensive it is. And also, I just enjoy doing this. I mean, an afternoon spent trimming this copper off here and finding out things that I didn't know before I started. I just find that much more enjoyable than sitting in front of a computer screen. So you will end up seeing this again. As I said, I want to play around with it a bit more. I've got a few more ideas on what to do with this, and ultimately I want to see what it's like inside of a waveguide as well. So if you did enjoy the video, please give it a thumbs up, and any comments or questions, drop them below. I'll do my best to answer them, and hopefully you'll join me on the next one.